First off, the IPCC and its collaborators were tasked with computer modeling and observationally measuring two very important numbers: the Earth's so-called power imbalance and its power imbalance feedback stability strength. I claim they have grossly botched both tasks in leading them to draw the totally wrong conclusion. I assert that they have not proven global warming. On the contrary, the observational data are fully consistent with no global warming. And without global warming, there's no climate change crisis. Their computer modeling is unable to simulate the Earth's surface temperature history. It's also, more importantly, unable to simulate anywhere near the Earth's albedo, which is the fraction of sunlight that gets reflected from the Earth. The reflected power and the associated power imbalance error are about 14 times bigger than the measured power imbalance, 25 times bigger than the imbalance error range. The observational data, therein lies the real flaw. They're fully consistent with no global warming. Okay, and also very important observation is that when you plug in the numbers and you apply conservation of energy, their claims for the cloudy sky albedo is wrong by a factor of 2. What's important for a factor of 2? No. Okay, the scientists who, if you look at the actual articles written by the scientists who are performing the power balance measurement, they admit up front that the available methodologies to them are totally incapable of measuring a net power imbalance with anywhere near the desired accuracy. And that is due to the fact that there are huge temporal and spatial fluctuations of the imbalance, along with gross undersampling of the data. The observational data, and here is the thing that really makes me angry. The data are fudged. The numbers just don't add up. And I will show you, pinpoint them for you, and show you exactly where to look so you can do the arithmetic yourself very simply. Moreover, the collaborator in NOAA has shown that or claims that there is an observed increase in extreme weather events. Their own data, I will show you, totally invalidate their own arguments. Finally, in part 2, I will talk about what I think is the important part of the talk. Sorry to put it for the last, which is what I believe is actually happening. And I point out that the IPCC has totally ignored the important features of clouds, the cloud cover variability in particular. Okay, the IPCC has really was given 2 very important tasks. They're sacred tasks because trillions of dollars rest on them getting them right. I claim they have botched both of those tasks. They were asked to computer model and observationally measure 2 very important numbers: the Earth's so-called power imbalance and its power balance feedback stability strength. Okay, what is the power imbalance? It's the difference between the power coming in and the power going out. The power coming in is sunlight. The power going out is reflected sunlight and re-radiated infrared power. Okay, this is actually the definition that is used, not temperature, for global warming. So from this, they claim there is global warming. they assemble a whole house of cards. I will go through that. It forebodes climate change, apocalypse, and catastrophe. Also, they calculate the strength of naturally occurring feedback mechanisms. Those are grossly in error, and I will show you how to calculate them correctly at the end. They claim only marginal effectiveness is hardly marginal if you include the actual values that you get from the cloud thermostat mechanisms. They are putting CO2 and methane as the cause of all of this. And they claim that they are responsible for everything. And correspondingly, they claim that $1 trillion a year need to be spent to mediate this. I assert they have not proven global warming. I assert that the feedback strength of the cloud thermostat mechanism is dramatically stronger than anything that they have calculated so far. And correspondingly, I assert that there is no climate crisis. Okay, well, how does this house of cards work? They claim with great certainty that the Earth has a net power imbalance. Power imbalance is indeed their definition of global warming, not temperature. It claims that there's more sunlight power coming into the Earth than there is lost cooling it. Lost power has got two forms: sunlight, irradiated far infrared radiation. More power in than power out is the definition of global warming. Okay, so how does the house of cards work? Global warming leads to climate change. Climate change leads to an increased frequency of extreme weather events and other bad phenomena. And the increased frequency of extreme weather events leads to a global apocalypse and climate change. NOAA claims to have observed this. That's totally false. Okay, the IPCC claimed to be caused by CO2. This contribution of CO2 are trivial by comparison. Correspondingly, they ask for trillions of dollars to be spent. So if you pull out the bottom card in the house of cards, global warming, which is based on power imbalance, then they have not proven it. So the house of cards collapse and the trillions of dollars are being wasted. Okay, this is the graph from the IPCC's 5th assessment report, which was actually also on the back of the American Physical Society News, where they show 40 different computer models. Not a single one of them can predict the Earth's temperature history, let alone, if you can't predict the temperature history, how can we believe that you can predict the future? Okay, the solid black curve is this is what they claim was the observed temperature. These are all the various predictions. Okay. This was first noted in important detail in Steve Koonen's recent book, Unsettled. It's very clear staring at this that there's something very wrong with the physics and or the observations. Okay, more importantly than the temperature is the actual power imbalance itself. This is a figure taken from Stevens et al. In 2015, which shows the claimed measured albedo of the Earth. What is the albedo? Albedo is the fraction of sunlight that gets reflected back out into space. Okay, that's the order claimed to be the order magnitude of 100 watts per square meter. You'll notice that there's an annual fluctuation of this. And I will get onto that in more detail of a far better measurement later on, measured from the Ceres satellites. And that's the black curve. The yellow, the various colored curves can't get, are the various CMIP5 computer modeling. They can't get anywhere near. They're off by the order of at least 10, 15 watts per square. They don't even have the right phase. And notice this is a non-sinusoidal phase. It's not simply caused by the eccentricity of the Earth's orbit. Okay. Here, I've added this scale, which assumes a constant solar input power of 340 watts per square meter. Actually, it's much bigger because there's another 18 watt per square meter change due to the variation in the solar constant. Okay, and you'll notice it's totally incapable of getting anywhere near correct simulation. And that's important because this is the definition of global warming. Okay, so the okay, so that's the theory from the computer modeling. Let's look at the observational data. Things get grossly worse here. Okay, so remember that we have power in. That's okay. The climate scientists refer to this as shortwave radiation. It's about 340 watts per square meter, but it's actually varying because of the eccentricity of the Earth's orbit. The power out is the reflected sunlight and the re-radiated infrared. Okay, measuring it should be straightforward, right? No, it's not. Problem is that the power in and the power out are very large numbers. They're in the order of hundreds of watts per square meter of surface area. And the difference between them is trivial. It's 0.2% of the power in. Okay, and that is what is the experimentalists are asked to measure. That is not easy to do, and especially when they are all grossly fluctuating and the data are terribly undersampled. We don't have anywhere near enough data coverage. Okay, how was it measured? Well, there are any number of measurements. The most important ones are the IRIBI satellite, Earth Radiation Measurement Experiment, and the Ceres, Terra, and Aqua satellites, and also the ocean heat content measured by an Argo buoy chain of data and water sampling from ships. And then further, there's a baseline surface radiation network used to, which is a bunch of pyroheliometers staring up at the sun in various places over the Earth. Okay, among these various measurement modalities, they're all in wild disagreement with each other. And there's large arguments among the readers of which one is right. And none of these actually show a convincing warming power imbalance. Importantly, most of the data are actually fudged. This is dishonest reporting of the data, and I will pinpoint for you, and so you can do the arithmetic yourself. Okay, where do you look? You look at the power flow maps that are on each of these various reports. Okay, there is a convention that one really primary convention is that where we calculate this all at the so-called top of the atmosphere. That's the simplest place because there are really only 3 numbers to look at. And so, okay. So here is typically how do you calculate that just from those 3 numbers? Okay, we have the incident shortwave power, that's the sunlight. The outgoing, that's the reflected sunlight. That's just the ratio, the albedo is the ratio of those 2. Okay, and there's the long wave or infrared radiated power. Okay, an important cross-check that you might want to remember is that the sum of the actual the error of the summation is the root mean square sum of the individual errors, and there's an immediate cross-check that you should pay attention to is that the final error has got to be bigger than any one of the input errors, and if you can claim a global warming only if the imbalance is greater than the error. Okay, so the earliest data goes back to Stevens et al. In 1981 and Ramanathan in 1987. These were based on 4 months, actually only partially analyzed data. They and remember, we had a non-sinusoidal variation in the albedo, so 4 months is gross undersampling of the data. Okay, so here are the numbers that they reported. Actually, if you they claim that the Stevens et al. Claims that it's +9. I calculate just from these numbers that they report +6.8. Ramanathan's numbers show an actual cooling. But wait, okay. Now, the National Academy report, Understanding Climate Change Feedbacks, looks at that, and their blunt comment was the observations do not meet quality standards. Okay, so things get very bad around 2009, 2012. Loeb et al. Used the ocean heat content data to adjust. That's one of our little no-nos, at least in the physics business. And they are the first to admit, and this is a direct quote, limitation of satellite data is their inability to provide an absolute measure of the net top of atmosphere radiation imbalance to the required accuracy level. So they say, okay, we can't really make this important measurement with satellites. So they reanalyze and take Ramanathan's data, which has these grossly undersampled data, and they just throw in new numbers to claim a net warming global power imbalance. They obtain new values by just saying, oh, well, we were throwing out all the satellite data. We'll keep the infrared re-radiation data, but we'll instead just do the power imbalance using the ocean heat content data from an Argo buoy chain. And this was apparently pressured from Hansen et al. Okay, and here is their data. Okay, here's the Aribi satellite, which they now say is cooling. Here's the oxygen heat, which and then finally in 2012, they give this very important number, 0.6 plus or minus 0.1. This is what I will refer to as a bad penny. Follow the bad penny, it will show up again. Okay, so Stevens et al. In 2012 merged with Loeb et al. And they both agreed satellites can't measure the imbalance that was needed, so they joined forces. and produced an important paper in 2012. This is probably one of the more important papers that is frequently, and they again are referring to what they call as an adjustment. In physics, we don't allow adjustments. Maybe in climate science you do. And again, the bad penny reappears. Here is their summation: 340 plus or minus 0.2, minus 100, minus 239. Okay, I add up these numbers, I get 0.5 plus or minus 3.9. Somehow this bad penny shows up again, 0.6 plus or minus 0.4. Okay, they use visibly incorrect data. It's just like some editor came in and said, oh, well, we can't use those numbers. Now, Loeb et al.'s were plus or error bars were 0.1. They increased those to plus or minus 0.4. And here's where you get the numbers. Here are the power flow diagrams from Stevens et al. Okay, I will show you more of these later on. Here's sunlight power coming in, reflected sunlight power, infrared numbers. Here they're trying to compare with the CMIP5 computer simulations. Their numbers, again, just don't add up. Okay, Lecoyer was one of the co-authors of the Stevens et al. He then wrote a minority report reporting the data and revised the Stevens et al. Numbers, saying, well, no, they don't really show a global warming. Okay, they did use adjustments, which they referred to as constraints. Here's their power flow map. Okay, notice Stevens and Loeb are no longer authors here. Here's the 340 watts coming in. Here's the 100 or so watts going out. Here's the outgoing. Along these are important numbers. These little wiggly lines down here are important numbers in passing. So along about 2010 and 2014, there were the original whistleblowers on this fudging of the data show up. These are Trenberth and Fasullo, who wrote rather important papers. They point out satellites are measuring only the top of the atmosphere energy balance, whereas ocean heat content data apply to the surface energy balance. You can only intermix the numbers if you understand fully what's going on in the atmosphere in between. Otherwise, you're doing apples to oranges. So they are very critical of Loeb, Stevens, Lecoyer, and Hansen's all claimed understanding. They point to a huge, quote, missing energy. And they ask the question, where does the energy go? Hansen et al. Respond and they say, oh, it's just all due satellite calibration errors. Trenberth, Fasullo, Balmasada respond, despite various considerations of the surface balance, there are still major discrepancies remain. Okay, so we now have a discrepancy between Stevens on one hand and Lecoyer on another. So they combine forces, just the two of them alone, and they write another paper in 2015, which is literally a mea culpa that yes, we cheated on our data. They claim that their choices are unjustified, ad hoc, and they still bring back the bad penny. Okay, offer what they admit effectively to the data fudging. They admit that yes, adjustments do need to be made to give you what they call closure between the satellite data and the ocean heat content data, and they still say, oh well, the bad penny prevails. Okay, so so at the end they say, well, they're both right. So we have here what from their paper. Here's the ocean heat content data. Here's what I calculate from their numbers. Here's Sarah's data that they're also commenting. Here's what I calculate from their numbers. Amazing. Oh, here's this bad penny again, 0.6 watts. Okay, so this continues on to more recent times. There was an important paper by Wild et al., or maybe it's Vild, I'm not sure how you pronounce it, in 2019 and 2015, and they report two different sets of measurements. They measure the so-called clear sky albedo and the all sky albedo. Now, if you actually look at their numbers, and I'll show you, I've got this in an appendix slide. If you add up and you apply conservation of energy, you find that their claimed albedo for a cloudy sky, which they don't show, is 0.36. That's a totally silly number. It's off by any reasonable number by a factor of 2. Okay, and there's the Wild et al. Diagram is copied directly by the IPCC's 6th assessment report, but they added additional fudges in the process. Okay, so here are their fudged error bars. Okay, here is the Wild et al. Measurements. Okay, I add up those numbers, I get 3.5 plus or minus 0.6 as the power imbalance. Okay, they claim, gee, where did this 0.6 come from? Okay, here's AR's the 5th assessment report. Here they're again claiming there's very strong global warming. I add up their numbers, I find no warming at all. Again, they're just bringing back the same old bad penny. Okay, they're all anything that's fudged, I have outlined here in red. They have a new innovative technique where they apply rounding, round off to increase the value. Okay, so they have they report their error range here as 340 with 340, 341 as the error limit range. Notice they've chopped off the last decimal point. So they round that up, and it really they round it up by ½ a watt per square meter. And notice that the reported imbalance is the order of ½ a watt per square meter. Okay, so here are their diagrams. Here's the 340 comment. This is Wild et al. On the left. This is the IPCC's 6th assessment report. Here we have our 340 watts coming in, 100 watts reflected. Okay, so the ratio of these two numbers is the albedo. Okay, here is the clear sky albedo, which is the ratio of these two numbers. That's about, let's see, what was that? What's missing here is the cloudy sky albedo. And if you use just simple conservation of energy, you find that that gives you the cloudy sky albedo is 0.36. Another important another important number to look at here is what's listed here as evaporation. 82 watts and 160 watts absorbed. I will come back to that and use those numbers. Those are very important numbers. They never mention exactly how they get them. Okay, mentioned before that NOAA has claimed that they saw an increased frequency of extreme weather events. It was an important Physics Today article written in 2012 by Livchenko and Karl. These were not scientists, these are politicians. This is an undersecretary of Commerce. And they, in that article, they claim there's an increased frequency of extreme weather events, especially in the last 3 decades. And it's some composite. They've created an extreme weather event index, which is a composite measure of hot spells, cold spells, droughts, floods, landfalling hurricanes, etc. They leave out EF3 plus tornado frequency. It's conspicuously absent from their limit. If you read Steve Koonen's book, he points out that that's actually decreasing. So they claim that this show it is obviously increasing in the last 3 decades. Here is their data that they present in that article. Remember this. I take the liberty of replotting it, and I replot it twice. This is an old trick that Alvarez and Towns taught me. I've plotted it twice, and I plotted it once forwards in time and once backwards in time. One of these is totally reversed. If you can't tell them apart, I assert that it's not obvious that the extreme weather event frequency is increasing in time. Okay, so what are the conclusions? The IPCC is claiming a net warming imbalance. Its claims are based on computer modeling and observational data. Both the computer models and the observational data are grossly flawed, and the data are totally fudged. Computer modeling predictions are totally unreliable. If you can't simulate the past, what makes us believe you can simulate the future? Not one of the observational modalities shows a power imbalance that shows warming. The observers are dishonest, and they have dishonestly fudged their reported data. I showed you where they had just simply changed the numbers at the very end from showing no warming to showing warming. If you don't believe me, pull down the articles and do the arithmetic yourself. It's pretty easy to do. Okay. Again, I've also shown you how NOAA's own data disclaim. So conclusion is from this is that there is no observed global warming. Correspondingly, there is no climate crisis. Our planet is not in peril. That the IPCC's claims are a totally dishonest hoax. Okay, so let me move on to what I think is the most important part of this talk, which is the cloud thermostat. Here is what I believe is really happening. It's clearly the overwhelmingly dominant controlling mechanism for the Earth's climate. It provides a very powerful feedback mechanism that stabilizes the Earth's climate and temperature. Its strength obtained from the observed large fluctuations in the power imbalance. Okay, which I'll show you is in fact totally huge. Okay, the way it works is it modulates the outgoing shortwave power, which controls the power imbalance, which is how it actually achieves its effect. The modulation amplitude is huge compared to the claimed power imbalance. Okay, there's a seemingly random fluctuation in the power imbalance. I claim is not random at all, but it's actually a crucial part of a thermostat-like feedback mechanism. And I will show you data from King et al. And from Stevens et al. 2015 that it's in that is quasi-periodic. It's just like the thermostat in your home. The power imbalance is never zero. The furnace or the air conditioning is always fully on or fully off. All that's happening is that the thermostat is modulating the duty cycle. Okay, so what are its features? We first describe underappreciated but they're highly conspicuous properties of clouds. Their variability and their strong reflectivity show that the mechanism involves the dominant use of sunlight energy by the flash. Remember those wiggly lines I showed you right in the middle of the power flow diagrams earlier. Okay, when you view it as a climate stabilizing feedback mechanism, it is by far the most powerful of any mechanism so far. I will go into detail later on, giving you those numbers. Okay, what are these conspicuous features? Well, you get them just by looking at satellite pictures of the Earth. There are lots of them available off the NOAA website or NASA website. Okay, here's the famous one of the Earthrise by the astronauts. Here we have a nearly cloud-free Earth. You want to see a really cloud-free Earth? Just go to Google Maps. Then zoom in, and there are no clouds anywhere. Gee, how did that happen, I wonder? Okay, here are some more cloud pictures. Here's the Pacific Ocean. This is the big cloud factory, which is very cloudy. Okay, what do you want to take home from looking at these pictures? Clouds reflect much more sunlight than the rest of the clouds appear bright white, no matter how you look at them. Effectively, the Earth is either bright white or totally black. Okay, the average reflectivity is typically about 0.8 or 0.9, just from staring at the pictures. For comparison, a piece of white paper has a reflectivity, or albedo, if you wish to use the word, is about 0.99. Remember that Wild et al. Claimed that the cloud reflectivity is 0.36. That's ridiculous. Okay, the rest of the planet is nearly black. It's much darker than the clouds. The average reflectivity of both ocean and land is about 0.16. That's the number that they measure. And the other important thing to notice is that the cloud coverage is highly variable. Another important feature of clouds is that they cast very dark shadows because of this strong albedo. If you can see this if you stand on a hillside and look down from an airplane. The clouds pass. Hillside or an airplane, and you look at clouds on a partly cloudy day, you can just see really dark shadows on the land floor. Another way to notice is if you have solar panels, just watch the power output drop when just a single solitary cloud passes in front of the sun. It's typically at least 50%. Worse yet, try reading a book indoors on an overcast day without turning the lights on. You can't do it. It's just too dark. You can ask the question, well, where'd all that sunlight go? Oh, sunlight? Water doesn't absorb sunlight. Oh, you see 10 feet down in a swimming pool, still bright white on the bottom of the pool. All that light got simply reflected by the bright white nature of the clouds back out into space, where it can no longer warm the planet. Okay, what does sunlight actually do when it reaches the Earth's surface? Most people believe, oh, well, it warms the surface, right? That's maybe true over land, but land is a trivial portion. It's only about 30% of the Earth. The important activity is all happening in the oceans. That's 70% of the Earth's surface. Where are the big numbers in all of this? Okay, we have 70% of the incoming sunlight falls on the oceans. So virtually all of the Earth's exposed water surface occurs on the oceans. That's the source of the clouds. Remember in the IAR6 power flow diagram, we had 160 watts absorbed, and we had, so 70% is 100 of that falling on the ocean is 112 watts absorbed by the oceans. Okay, that diagram showed we had 82 watts used for evaporating water and not for heating. So 82 over 112 is 73%. That means that 73% of the input energy is being used not for warming the Earth, but simply for making clouds. Okay, so where are the good cloud measurements? All of the most important is an important paper by King et al., who actually separated out ocean and land observations by the Terra and Aqua satellites. The upper curve is this is the cloud fraction versus time on their graph. This is about 67% is the cloud cover fraction over the ocean. The order of 55% is the cloud cover fraction over. It's a huge difference. Nobody seems to have noticed this. And you'll also notice that the two Terra and Aqua satellites were 3 hours apart in sun synchronous orbits. And notice there's a huge variation. It goes backwards over land and then over the ocean. And this is the difference in cloud cover that occurs in about 3 hours. And that's repeatedly averaged over 13 years. There's that difference. Okay, so if you have the cloud cover fraction and if you know the albedo of the clouds, you can work out backwards, well, what's the total power that is being reflected? Well, okay, so I've added 2 scales here, depending upon what you want to assume. Okay, so the left-hand curve here uses the IPCC's estimate of cloud albedo of 0.36. More realistic estimate of cloud albedo is about 0.8. Here I'm assuming a constant solar input power. So we have huge fluctuation, and especially we have a huge fluctuation for clouds that pass from the ocean over land. This is the order of 55 watts per square meter from clouds traveling from. Now that's what controls the Earth's weather. At least it certainly does in the North American continent, where the clouds that hit the North American continent are all effectively coming from the Pacific Ocean. Okay, there we go. And recall, okay, so we have this huge fluctuation up to 55 watts. And remember that the IPCC says, well, we've measured it all very precisely to be 0.7 watts plus or minus 0.2. I find that I'm very skeptical. And if you've noted, remember that earlier slide by Stevens 2015, they don't even recognize that this annual fluctuation in albedo is due to cloud cover variation. Okay, so what is this thermostat model and how does it work? Okay, remember we've got 73% of the input energy is used not for warming the earth, but instead for evaporating seawater and making clouds. And remember we have this huge variation in cloud cover that's occurring several percent just in a matter of 3 hours repeatedly. Okay, the temperature control works the same way that it does in your for your home thermostat. If it's too hot, it turns off the furnace. If it's too cold, it turns on the furnace. Suppose you have a small heat leak. Somebody leaves a bathroom window open. That's not going to affect the temperature of your house. For CO2, that's the order of about equivalent of 0.2 watts or 2 watts per square meter, 1.6 watts per square meter. That's a trivial heat leak compared to these huge fluctuations that we're seeing. Okay, so if you suppose we have the Earth cloud cover is too high, and the Earth's surface temperature is too low. Okay, clouds produce shadows. The cloudy days are cooler than sun. A high cloud cover equals a highly shadowed area over the oceans. That's 70% of the Earth. The reduced sunlight reduces the evaporation rate, which is a very sensitive measure of temperature. And the sunlight is low because we don't have enough. We have too high cloud. So what's the response? The cloud cover fraction starts. If we reduce the evaporation rate, we reduce the cloud cover fraction, which starts to decrease quickly. The cloud cover fraction decreases. The temperature increases. Fraction is no longer too high. Equilibrium is restored. The same thing occurs in the opposite direction. So it depends on what assumption you use for cloud albedo. We got anywhere between 18 and 55 watts available from a cloud cover. It's actually even more than that if you want to include the additional 18 watts due to the ellipticity of the Earth's orbit. So there's a huge furnace power available for stabilizing the temperatures. So I assert that these two opposing processes provide an equilibrium thermostat that stabilizes the Earth's temperature. Okay, let's look at this as a feedback mechanism. Remember I mentioned that the IPCC's second important task was to estimate the feedback stability strength and its sensitivity to external perturbations, like, for example, greenhouse gases, volcanism, etc. Okay, we have clearly huge variations in outgoing power. Just even Stevens' 2015 slide that. But obviously, Earth maintains a surprisingly stable long-term temperature. Why is that? Well, everybody recognizes that we got to have something stabilizing it, that there are feedback mechanisms. They are outlined in any number of studies. Earliest was by the National Research Council National Academy report in 2003. And the second one, a Sherwood et al. Report. I am grateful to Steve Coonan for calling my attention to this report, and for chapter 7.4 from the sixth assessment report. I'm going to use, and I show in detailed in a slide, an Appendix C slide, which I'm available for questions. And they have Sherwood et al. Have an overly restrictive assumption about what's allowed as an intermediate variable. That's totally silly. Okay, so you can use their methodology to evaluate the feedback strength. Okay, and there are two different ways to do it. Remember, there were two different values for cloud albedo. If you use the IPCC's choice, you have minus 5.7 watts per as the per meter squared per degree Kelvin. If you use 0.8, you have minus 12, and it's much stronger than the so-called Planck feedback, which they use. And I might point out that Planck had nothing to do with it. It's totally misnamed. Planck's law was discovered, radiation law was discovered 20 years after the Stefan Boltzmann relation of the sigma t to the fourth. They can't even get the name right. Okay, so I plotted those on the 6th assessment reports figure, and in either scenario, you can see that the cloud thermostat is the strongest model. It's very powerful. Okay, this top portion of the power flow diagram is directly from the 6th assessment report for what the cloud feedback mechanism strength is. Here is the net where you have the sum of all the various mechanisms. Here's what they call for clouds. They say it's a positive feedback. You put in my numbers, that's down here minus 5.7 or minus 14. So if you add those up to all of the others, that means that this is the strength of the feedback mechanism, which is dramatically higher than what the IPCC has calculated, and which is similar to what Sherwood et al. Have calculated. So what are my conclusions from part 2? That we have the cloud thermostat mechanism that I have described. It is clearly, I believe, shown that it's overwhelmingly the dominant controlling feedback mechanism that controls the Earth's climate and temperature. It prevents global warming and climate change. I've shown you the calculated strength. And the important thing to recognize here is that this is nature's own solar management system. There has been trillions of dollars being spent for mechanisms or for man-made systems. Totally waste of time if you plug in the numbers to make a business model out of them. They're totally ridiculous when you try to look at how much power, how much control you really need. I assert that there's already a solar radiation management system. It exists. It's built into nature's own cloud factory. That's the oceans. It works very well, stabilize the Earth's temperature on a long term, and most importantly, is totally free. Okay, so the IPCC gets away with taking recommendations for policymakers. I will do the same. First off, there is no climate crisis. There's clearly an energy shortage crisis. We have a huge population that needs energy, but cutting off all the various energy supplies is clearly the wrong thing to do for the sake of the world. Okay, the scapegoat on all of this that IPCC has is CO2 and CH4. We're spending trillions of dollars to limit CO2 and CH4. The important thing to realize is that CO2 and methane are not pollutants. They need to be removed from the list of defined pollutants. That one measure alone will save us trillions of dollars. I might also point out a plug for the CO2 Coalition, which points out that the CO2 is actually beneficial. It's good stuff. Okay, so what should we do? We're spending trillions of dollars needlessly. We should immediately terminate all the programs for carbon caps, carbon credits, carbon sequestration, carbon footprints, zero carbon targets, carbon taxes, anti-carbon policies, fossil fuel limits that are propagated into our energy policy. The government requirements us for subsidies on associated industries should be totally eliminated. If they can't stand on their own, then they don't deserve to compete. These include electric subsidies for electric power, solar and wind power, all of these various geoengineering projects, including the solar radiation management. If you run a sharp pencil through them, the business models, they're totally ridiculous. They don't work, and they're just a waste of $1 trillion. So I want to paraphrase Senator Everett Dirksen, remember from the Vietnam War era, $1 trillion here, $1 trillion there, and pretty soon you're talking real money. Okay, I have available for the question period mentioned. Here is the important observation regarding how I got the albedo from clouds. It's a very simple theorem. It says we have that the all-sky albedo is just the area-weighted sum of the two component areas of the Earth. Ramanathan and 87 divided the whole Earth into cloudy and cloud-free. And so if you know these, and you can also make a corollary which shows that if you can calculate the albedo of the clouds if you know all of the other important parameters. Here is in Appendix B. I apply that to the Wild et al. Measurement of the all-sky albedo. Okay, the all-sky albedo is 0.3, 0.16. You plug it into the corollary, you get the cloud albedo is 0.36. And that's in gross disagreement with actually direct measurements of cloud albedo. Here is the feedback analysis from using Sherwood et al.'s method. They simply calculate the derivative of the power imbalance with respect to the Earth's temperature and use the chain rule. Here, what they have prohibited one from using is the cloud fraction as a intermediate parameter. So if you plug in the numbers, you can all of the important numbers is the derivative of the downward flowing shortwave power, or sunlight, if you will. Okay, and to calculate the cloud cover sensitivity, and you get really three important factors. There's from the fractional clouds and the albedo of the clouds, top of atmosphere input power, that's the 340 watts. And the only remaining power is the partial derivative of the cloud cover as a function of temperature. That's pretty straightforward to measure. It's about 7%, and that is simply due to the temperature dependence of the evaporation rate of seawater, which is about 7%. per degree Kelvin. Okay, I think that's about all I have to say.